Okay, so today we are doing the second to last section of chapter 8, which I thought was the last, but I was wrong about. And that is 8.6. Excuse me, radical expressions and problem solving. So without further ado, let's do part 1, solving equations that contain radical expressions. So first we have some general steps for solving these problems, and then we're going to do a bunch of example problems that take us through specific examples of how we do these steps. So that being said, our steps for solving a radical equation include isolate the radical on one side of the equation, raise each side of the equation to a power equal to the index of the radical and simplify. If the equation still contains a radical, repeat step 1 and 2. If not, solve the equation. And step 4, check all proposed solutions to the original equation. That one's important because sometimes when you plug it back in to check, it does not work. So you definitely need to be careful that you are checking solutions, okay? So first up, we have square root of 2x minus 3 equals 9. So step 1 is isolate the radical. That is already done for us in this case. We can see that 2x minus 3 equals 9, or 2x minus 3 is under our radical, and then that is equal to 9. I don't know why my Apple Pencil is being so far behind. Let's see here. Square root of 2x minus 3 equals 9. Okay, and so we know that our index here is 2, right? Because we're taking a square root. So we are going to raise each side of the equation to a power equal to the index, so that squaring a square root gets rid of our square root. So we have 2x minus 3 is equal to 9 squared, which is 81. Check to see if the equation still contains a radical term. It does not, so solve the equation. So we're going to add 3. So 2x is equal to 84 divided by 2. X is equal to 42. And then last but not least, we have to check it. So our original equation is square root of 2x minus 3 equals 9. So checking it would be square root of 2 times 42 minus 3 equals 9. 2 times 42 is 84. Square root of 84 minus 3 equals 9. 84 minus 3 is 81. Square root of 81 equals 9. So 9 equals 9. That checks out. Check, smiley face. Our solution works, okay? Because that is a true statement. 9 equals 9. All right, let's do another example. So square root of negative 10x minus 1 plus 3x equals 0. So step 1 is to isolate the radical. So that means on one side of the equation, you want only the radical expression. So in this case, we have plus 3x on the left side as well. So we want to get rid of that. So we're going to have square root of negative 10x minus 1 equals negative 3x. And then we want to go ahead and use the power rule to eliminate our radical. So we're going to raise it to the power of our radical, which was a square root. So we will be squaring. Squaring a square root gets rid of that. So we have negative 10x minus 1 is equal to negative 3x quantity squared is equal to negative 3x times negative 3x, which is equal to 9x squared. So we're going to have negative 10x minus 1 equals 9x squared. And then, since this is a quadratic equation, we're going to need to solve by factoring, which means that I'm going to want one side equal to 0. So I'm going to get 9x squared, 0 equals 9x squared, plus 10. Oh, why does that do that? 9x squared plus 10x plus 1. And then I'm going to go ahead and factor that. So I'm going to use my x method, 9 in the top, 10 in the bottom. That's going to be 9 times 1. And then we have to go ahead and remember to divide by that coefficient of x squared, which is 9, divided by 9. 9 divided by 1 is 1. So this factor will be x plus 1. And this factor over here will again be denominator, 9 times x plus numerator, which is 1. So we have x plus 1 times 9x plus 1 equals 0. And then we want to go ahead and solve for those individual factors. So x plus 1 equals 0, x equals negative 1. And then we have 9x plus 1 equals 0. So that is going to be 9x equals -1. So x equals -1/9. And then we have to go ahead and check these solutions. So I'm going to do that in a different color. So let's try x equals -1/9. Our original equation is square root of -10x minus 1 plus 3x equals 0. So I'm going to plug in -1/9. -10 times -1/9 minus 1 plus 3 times -1/9 equals 0. So I'm going to have square root of -10/9 minus 1 plus 3 divided by -9, which is going to be -1/3. Or I'll put it -3 divided by -9. 3 divided by -9 equals 0. So -10/9 minus 1 is going to be -10/9 minus 9/9. Do a common denominator there. So that is going to give me the square root of, negative times negative there makes that positive. So that's going to be the square root of 1/9 minus, this simplifies to -1/3. So it's going to be -1/3 equals 0. The square root of 1/9 is 1/3. So I'm going to have 1/3 minus 1/3 equals 0. And that is 0 equals 0. So that is true. And we know that -1/9 is a solution. And now we want to go ahead and check -1. This one will be a little bit easier. Don't have to deal with those fractions. So if we have x equals -1, I'm going to have the square root of -10 times -1 minus 1 plus 3 times -1 equals 0. The square root of 10 minus 1 minus 3 equals 0. So that's going to be the square root of 9 minus 3 equals 0. That's going to be 3 minus 3 equals 0. 3 minus 3 is 0. 0 equals 0. Checks out. So in this case, both of our solutions work, as we have double checked. So the solutions include -1/9 and -1. Let's do another example. Next up, we have the cube root of x plus 1 plus 5. The cube root of x plus 1 plus 5 equals 3. So we want to isolate our radical. So I'm going to subtract 5 from both sides. Get the cube root of x plus 1 equals -2. And then you raise each side to the power of your index. In this case, it's 3. So I'm going to cube both sides. That's going to get rid of my cube root. And I'm going to get x plus 1 is equal to -2 cubed, which is going to be -8. I can subtract 1. So I'm going to get x is equal to -9. And then I have to check that in the original equation. So I'm going to get the cube root of -9 plus 1 plus 5 equals 3. That is the cube root of -8 plus 5 equals 3. The cube root of -8 is -2 plus 5 equals 3. 3 equals 3. Checks out. Not -9 is in fact our solution. Next up, we have the square root of 4 minus x equals x minus 2. So isolate the radical, done, it's already isolated. Raise it to the power of our index, so that's going to be squaring each. That gets rid of our square root, so we get 4 minus x equals x minus 2 quantity squared is equal to x minus 2 times x minus 2. So we're going to have to FOIL out that bad boy. We're going to get x squared minus 2x minus 2x plus 4. So we're going to get x squared minus 4x plus 4. So we get 4 minus x equals x squared minus 4x plus 4. Let's set that equal to 0 to solve it. So we're going to subtract 4 and add x. Subtract 4 and add x. We're going to get 0 equals x squared minus 3x, and then that plus 4 minus 4 goes ahead and cancels. In order to factor this, I'm going to factor out my greatest common factor of x. So I'm going to get 0 is equal to x minus 3. And then I can set each individual factor 0. So x equals 0, x minus 3 equals 0, x equals 3. So I have to check x equals 0 and x equals 3. let's go ahead and check x equals 3 first. So the square root of 4 minus 3 equals 3 minus 2. So the square root of 4 minus 3 can be square root of 1 equals 1. The square root of 1 is 1. 1 equals 1. Check. That checks out. Let's check 0 now. So if we have the square root of 4 minus 0 is equal to 0 minus 2, the square root of 4 minus 0 is the square root of 4 is equal to -2. And so the square root of 4 is 2. 2 equals -2 is not a true statement. So 0 does not work as a solution in this case. All right, let's do another example. Lots of examples this time. Actually, only one more, I guess. So next up, we have the square root of 2x plus 5 plus the square root of 2x is equal to 3. Okay, so we want to get one radical alone by subtracting the square root of 2x from both sides. So it's minus square root of 2x. So I'm going to get the square root of 2x plus 5 is equal to 3 minus the square root of 2x. Okay, and then I'm going to use the power rule to get rid of my square root. So I'm going to square over here. That's going to get rid of this, and I'm going to square this. So this side is going to give me 2x plus 5. And then over here, I have to FOIL out 3 minus square root of 2x times 3 minus square root of 2x. So that is going to give me 9 minus 3 square root of 2x minus 3 square root of 2x plus 2x. So then I'm going to get 9 minus 6 square root of 2x plus 2x. Okay, so now I have 2x plus 5 is equal to 9 minus 6 square root of 2x plus 2x. Okay. Wow, that was a lot of sneezes in one lecture. So now I want to isolate my radical term. So I'm going to subtract 2x, and I'm going to subtract 9. So I'm going to get 2x minus 2x. So that makes my 2x's go away. And 5 minus 9 is going to give me -4 equals -6x, or not 6x, -6 square root of 2x. I don't know why that line turned out so funny. I'm going to get -4 equals -6 square root of 2x. If I add 6x to the other side and add 4 to the other side, I can make both these positive. So 6 square root of 2x is equal to 4. And then I'm going to have to go ahead and square both sides to get rid of my square root. So square, that's going to give me 36 times 2x is equal to 16. That's going to give me 72x equals 16. I can divide by 16, divide by 72. So x is equal to 16 over 72, which simplifies to 2/9. So I have 2/9, which I now need to go ahead and check in my original equation. This could get a little bit gross, but we're going to do it. So 2/9. The square root of 2 times 2/9 plus 5 plus the square root of 2 times 2/9 is equal to 3. That was from my original equation. So 2 times 2/9 is going to be 4/9 plus 5. The square root of 4/9 plus 5 is going to become 45/9. Plus 2 times 2/9 is going to be the square root of 4/9 is equal to 3. So the square root of 4/9 I can break up, 45 plus 4 is going to be 45, 46, 47, 48, 49. Square root of 49/9 plus the square root of 4/9 equals 3. I can use the quotient rule, so I can think about this as square root of 49 over square root of 9 plus square root of 4 over square root of 9 equals 3. Square root of 49 over square root of 9 is 7/3. Square root of 4 plus 2/3 thirds equals 3. 7 plus 2 is 9. So that's going to be 9 thirds equals 3. 9 divided by 3 is 3. So I get 3 equals 3. Checks out, and my solution is correct. So 2/9 would be my answer to this problem. So this problem goes back to that step 3 that we have written that says if you have a radical, you're going to need to repeat steps 1 and 2. So that was an example of that. And then part 2 is pretty straightforward using the Pythagorean theorem. So recall if A and B are the legs of a right triangle and C is the hypotenuse, then A squared plus B squared equals C squared. So a little bit of a picture there would be like this, A, B, C. Then we know A squared plus B squared equals C squared. Okay, so types of problems that would look like this would be example, find the length of the unknown length of the right triangle. And I wasn't able to figure out how to put the actual image on here, but I wrote it. Shorter leg is 4 meters, so this would be 4 meters, and hypotenuse is 10. So then we know this is A, this is B, this is C, so 4 squared plus B squared equals 10 squared. 16 plus B squared equals 100. B squared is equal to 100 minus 16, which is 84. And then to get B alone, we will take the square root of 84. So B is equal to the square root of 84, which we can actually simplify a little bit because that is equal to this 84 is divisible by 4. So we can think of square root of 84 as square root of 4 times 21, square root of 4 times square root of 21, so 2 square root of 21. So B is equal to 2 square root of 21. So these types of problems are pretty easy application in terms of just using what we know about radicals and applying it to the Pythagorean theorem, which has to do with square roots. So that's all I have for today. Have a lovely weekend. And there is a little bit more of chapter, there's a little bit more of chapter 8 that we will do next week. Thanks for watching, guys. Have a good day.